Okay, now I would like to give some brief introduction about the random signals. Since since random signal is something which is I believe that you are not familiar with. Okay, and then one of the reason that why we need to explain a little bit about the random signal, because we know that one example of random signal is our noise. Okay, so why our noise can be categorized in random signal. Okay, if you talk about the random signals, okay, random signal is I just we can try to discuss this whiteboard. So this is the example of one dimensional random signals. Okay, I just draw it continuously. Okay, even I draw it continuously or in analog way. Okay, you can also assume the digital one dimensional digital signal random signal should also look something like this, but in digitized version. Okay, so this is the example of random signal. Okay, when we talk about the random signal, it is something that cannot be predicted or cannot be represented or cannot you know produce the approximation, because when we talk about the random signal, the behavior of the signal is randoms, meaning that they produce value, the amplitude or for each and every point, okay, to the entire this time domain. Okay, the amplitude is behave randomly, or it's generated randomly, it produced randomly. So this one is in contrast with this one. Okay, this one, okay, if you refer to some textbook, they call this one as I think they call it as a deterministic signals. Okay, deterministic. Okay, when we talk about the random signal, actually the one that in contrast with the random signal is deterministic signal. Okay, meaning that if you talk about the deterministic signal, is something that can be determined. Okay, and in other words, it can be when we talk about deterministic signal, is signals that can represent, can directly represent by mathematical equation. Okay, this is the example. I just draw some example of deterministic signal. Okay, one of it is your sinusoidal signal, because this signal can be expressed, okay, can be represent by mathematical expression, direct mathematical expression, which is this is actually, we can write the expression is xt is equal to some amplitude and sine. Okay, I just write the formula there, and then you have some things here and t there. So in other words, if you talk about this signal, okay, it can be represented by some mathematical expression like this, direct equation like this, to represent the signal. However, for random signal, you don't have any equation, direct equation for it. You don't have any mathematical expression that represent that signal, because the randomness behaviors there. Okay, it's unpredictable, and you have many uncertainty there. So then what when we talk about this random signal, and how mathematician try to represent some equation to to represent that random signal. Okay, one way that mathematician do is by by model the probability of that random signal, because when we talk about the probability, that is a only way to represent your random signals. Okay, the question is why probability. Okay, if you remember when you learn about the probability in your secondary school. Okay, if you remember why you need to count the probability, why you need to calculate the probability. Actually, probability is related to how frequent, or we can say what, for example, what is the probability that event happen. Okay, what is the probability of that event happen as compared to other event. Okay, if you remember this, that is that is the concept of probability. And one way that when you in your secondary school, you always implement the probability in finding your for example, the life event. Okay, any event happen in your life. Okay, and how you do is by, you know, you just count how many that event happen. Okay, you just count how many time that event happen, and then you divide by the total event. Okay, you means that you divide by the total or the rest of the other event, and then you can find the probability of that event happened as compared to other event. So why when we talk about the live event, we always model with the probability. Okay, why mathematician always perform or present the live event using the probability? That is because the one that I think maybe some of your, you know, when you learn this in secondary school, that maybe your teacher don't um, explain to you, is because when we talk about the life event as a humankind, okay, we always assume that life or anything or any event happen in our life is you know, unpredictable, is something behave randomly. Okay, because as a humankind, you don't, you know, you cannot, you don't know what happened to the what happened in your future. So that's why anything or any event happen in future for humankind is unpredictable. So that's why the event or life event is also, okay, is also you know, behave randomly. So that's why when we can consider also the life event also can considered as a random signal, something which is randomly and unpredicted. So that's why when we model something, or we want to model our life event, or when, and we want to, you know, if the mathematician want to represent mathematical model about the life event, then one way they can do is by using the probability, because probability is one way to represent uh, to represent the life event. Okay, so that's why you learn the probability in your secondary school. Okay, and then of course because of the randomness of the life event, and I just, this one is just some additional knowledge. Okay, if you talk about the destiny in your life, okay, you are treat your destiny as a random behavior, because you cannot predict your destiny. As a humankind, from the perspective of humankind, destiny is random, but from the perspective of God, destiny is deterministic. So I hope that that is the principle why when you do, when you know, count your event, your future event, or your destiny, you are always model as a probability, because you cannot predict your future. And your future is if you model your future, is a random signals. So that's why one way, you don't have any direct mathematical expression to represent the event or the signal. So that's why you are you know, you formulate the probability models for your event or for your random signal to represent the random signal. So same goes to this random signal. Okay, if you talk about the random signal, one way you can do is you can only represent the random signal through the probability. Okay, that is one way. Okay, so how to generate the probability that represent the signal. Okay, again, this one have been discussed earlier in chapter 2. Yeah, when we talk about the histogram equalization, if you remember, one way to implement the one item that very important to formulate the histogram equalization, actually when you generate the PDF, which is probability distribution function. Okay, actually probability distribution function is the one that can represent, actually the probability distribution function itself is a model of that random signal. Okay, in other words, one way to represent the random signal, actually you can present the random signal by you can probability distribution function is one way to represent the random signal, because probability distribution function itself is what we call as a probability. Okay, probability of everything or every event happen in your life actually have been modeled by probability distribution function. Okay, but let's go through this one first. Later I will like to relate this one with with the one that you learned before in probability or in secondary school. Okay, so if you remember, okay, if you remember that okay, what is probability? Of course, probability is like I said before, you, in order for you to count the probability, you need to count how frequent that event happen, and then you need to divide by the entire event, or the entire set of event. That is how you count the probability. So that have been discussed earlier in the chapter 2. Okay, one way to get the probability is when you the things, or how actually you get the probability is through the counting the histogram. Okay, because histogram represent how frequent that value as compared to, or with respect to the total numbers. Okay, what are the probability that one occur, what are the probability, for example, 1 occur, what are the probability 1.5 occur. So what are the probability, let's say number such as 15 happen inside that event. Okay, so same goes to the random signal. Okay, one way is you can plot the histogram. Okay, we just put the roughly how actually we can plot the histogram. Of course, if you have some if you divide the amplitudes there into certain group, then you can plot the histogram. Okay, we just assume that let's say, I think it's better for me to just divide this one into certain region like this. Okay, the one we divide this one into 4 region. Okay, we just divide this one into 4 region. Okay, not 4 region, 3 region. So you have the region which is close to the 0 there, and then this one is the upper part and the lower part which is far from the 0 there. So if you think about, let's say this is a set of random number. Of course, when we talk about the random signal, it's about a set of random signal, random numbers. Okay, because it's a randomly and unpredicted. Okay, it's unpredicted there, but it's behave randomly. There's a random value after this point, then you have this point, after this point you have this point. So it's a random generated randomly. So again, if you want to count the how many that's why when you want to generate the probability, you need to generate the histogram first, because histogram represent how frequent that numbers occur in that event, in a certain time, how much that value occur. So that's why one way you can generate histogram. Let's say this is the histogram. Okay, I just give you a rough histogram. We just estimate the histogram. It's not an accurate histogram here. Okay, let's say this is the histogram. Okay, this is the histogram. Okay, if you just simply estimate the histogram, for sure you can find out the one that is close to the middle, which is close to this horizontal axis here, should occur the highest. The frequent should be the highest. Okay, among others. Okay, then I just draw one histogram, a very high histogram there. Okay, I just draw it one line. That actually that is a bar. It should not bar. It should be bar, but let's draw just represent by that line. That is actually the bar. This one is the bar, one bar. And then if you going towards this direction, okay, the frequent of that number will keep drop. Okay, for example, I draw something like this. Okay, it will keep drop. Okay, same goes to this side. Okay, it might have certain number there, but it will keep drop. Okay, that is the histogram. I just draw it in this is assume that this is your histogram. I just draw it in that way. Okay, in that way. So that is how it look like. Okay, this is the okay, just draw the axis there. I just draw the axis. This one is the this one is the frequency, okay, of the histogram. And then of course if you draw it in proper way, okay, if you want to convert into PDF, again, if you remember, if you convert it into PDF, it's just a normalized histogram. Okay, PDF is just a normalized histogram. Okay, this is my PDF. Okay, I just put it the probability of let's say this signal is X, the probability of X occur. Okay, this is my PDF. So if I draw it, I should see the same shape there. The difference is just now is a normalized, meaning that you just normalize the amplitude there by dividing the frequent the frequent here with the total number of frequents. Okay, but if you talk about the shape should be similar. Okay, you will see something like this. Okay, so that is when we talk that. Okay, this is PDF. Okay, just try to highlight this one, and before you forget, this is the PDF, probability distribution function. So again, like I said, that is how we represent the random signal. Okay, we cannot do something like deterministic signal, because deterministic signal can be represented by mathematical expression, can be represented directly by some mathematical expression that actually represent that signal. However, for random signal, you cannot have something directly like this. But one way you can do is you can represent the random signal by having the probability concept, where you represent the random signal with this what we call as a probability distribution function. Okay, if you remember why the shape is like this, okay, if you when you learned probability in your secondary school, if you remember, this shape is actually represent your normal distribution. Okay, this is what we call as a normal distribution, or in other words, our probability distribution function, if the shape is something like this, then we also can call as a normal distribution. Okay, normal distribution. This is the word that you always see when you learned in your secondary school, if you remember that. Oops, sorry. Okay, normal distribution. So why they call it more normal distribution is because this is how the random signal or the random event happen in your life normally distribute. Okay, meaning that for sure something which is at the center will, the probability of that event occur is very high. Okay, why the center is very high? Again, if you talk about this signal, if you count the mean of this set of number, or this set of signal, the mean is actually always almost at the center there. Okay, the mean is here. Okay, if you talk about the means, okay, means the mean. So that is same goes to this one. Okay, in general, no, mean is always at the center, and then how you know how far this one going, how if you talk about the range of the how the signal is swing, actually is depend on the variance, because if the variance is high, then the if you talk about the range between, or the range that generated signal occur in that represent this random signal is depend on the variance. So that's why, if you remember, why they call it this normal distribution. Okay, if I draw it in this shape, okay, I think this one might you know, give you some idea actually what happened. Okay, it's look like the bell shape, where actually this is the mean. Okay, this is the mean, and this one represent your variance. Okay, so if you remember, when you model your probability, when you count the probability, the live event probability, you always refer to this type of normal distribution actually, or in other word, the function of the normal distribution is in shape of it's look like a bell shape. Okay, it's like a bell shape there. And another name for normal distribution is also known as a Gaussian distribution. Okay, Gaussian distribution. Why they call it Gaussian distribution? Because the bell shape itself, when we talk about the bell shape graph itself, this is actually one function that can model this bell shape is called Gaussian function. Okay, Gaussian function. So that's why they call this one Gaussian distribution, or another name for Gaussian distribution is Gaussian normal distribution, because we always said that any event that is the highest event happen, or the highest number, the highest probability always which is close to the mean, because when you count all number or set of number, if you calculate the mean, any number which is close to your mean will always occur. Will always provide the highest or probability, or it will occur very frequent as compared to the one which is far from the center or far from the means. So that's why when we draw the histogram, or when we draw the PDF, it's a kind of bell shape, and this bell shape is known as a normal distribution, or another name for normal distribution is Gaussian distribution. And the bell shape itself actually can represent by Gaussian function. Okay, just to relate what you have learned in your secondary school. I don't know what about other country, but in Malaysia, when we learn about the probability, if you remember, when during your exam, you will be provided with what we call as a buku sifir, or buku sifir 4 angka. Okay, just to relate with what you have learned in secondary school, if you remember, when you learn about the probability, and when during the final exam and so on, when you want to answer the question related to the probability, the examiner always provide you with this book, what we call as a buku sifir. I don't know what about the other country. I believe they also do. I believe they also do the same. Okay, this one. Okay, so why they provide you with this buku sifir is because of they want you to refer to this thing. If you remember, yeah, this is one of the content. So you can see there, this is balance sheet. So actually this is the PDF. Okay, this is the PDF. Okay, when you count the problem, when you want to solve a problem related to probabilities, then because you want to count what are the probability that event happen, then when you want to calculate that, actually you are referring at the PDF. Okay, and you assume that your PDF is in bell shape, and this bell shape is actually what we call as a normal distribution. And another name for normal distribution, because this is bell shape, so if you see this function, actually this function is Gaussian function. Okay, this expression here is represent the Gaussian function. So in other words, any function which is in shape of bell shape actually is a Gaussian function, and any histogram that follow the shape of bell shape is also known as a Gaussian distribution, and is also known as a normal distribution. Okay, just try to relate with this one, because I believe that when you learn earlier in secondary school, they are not exposed with this thing. Okay, why you need to refer to this book to answer the probability question, because you are always assume any event happen in your life is treated as a random signal or random event, and then you assume that your random signals or random event can be modeled as the PDF, and not just PDF, but the PDF itself, you assume the model is a Gaussian model or a normal distribution model. So that's why you always draw in this bell shape. Okay, that's why most of the time, or the most of the common probability distribution function that you use for represent your random signal or random event is you are modeled as a bell shape, which is also called, okay, that is, the bell shape is called as a Gaussian function or Gaussian distribution, or in this case is a normal distribution. Okay, I hope you clear about this one, because later in this chapter we also give you some, you know, give you some expose, instead of random signal can model as a normal distribution or Gaussian distribution function, or in other words, the PDF you are assumed to be the Gaussian model. Okay, there's a there also other PDF or other type of shape. Okay, it's not just a normal distribution, but what you have learned before is just you are given with, or you are exposed with a normal distribution, which is, when we talk about the normal distribution, they are using the bell shape, and that bell shape is a Gaussian model. Okay, but if you talk about the random signal, you cannot, okay, it not just you can, okay, you what I mean is that random signal is not it's not just can be represented as a Gaussian distribution. There's also other distribution as well. There's also other distribution model itself, other distribution model that can represent the random signal. However, for the time being, why you still always use the Gaussian function, because that's why they call it normal distribution. Okay, when we talk about the random signal, that is how the random signal normally happen. Okay, the something which is occur higher should be close to the mean value. Okay, but instead of this one, you also have many other model as well. Later we'll discuss about other model as well. Okay,